Okay, Assalamualaikum and good evening. This is the explanation of the problems requested. The first one was on question 3, yeah? Question 3, quiz 3. Yeah, quiz 3, problem number 2. Yeah, problem 2. The question was asking for elements that can be isoelectronic. Remember, in order to be isoelectronic, normally these elements will form ions except for group 18 elements. Right, let's have a look at option A. We have nitrogen, yeah, nitrogen, and then oxygen, neon, and Mg. Of course, only neon will stay in the form of atom, whereas nitrogen, oxygen, and magnesium will form ions in order to be isoelectronic. If we have a look at the configuration of nitrogen, yeah, nitrogen has 7 electrons, 1s2, 2s2, and 2p3. When it forms ion, of course, nitrogen needs 3 more electrons and it will form N3 minus, in which the configuration here will become 2p6. Similarly, for oxygen, oxygen is just next to nitrogen, 8, and its original configuration is 1s2, 2s2, and 2p4. And when it becomes ion, of course, it needs 2 more. And oxygen will have the charge of 2 minus. And finally, again, the configuration at the end will be 2p6. Now let's have a look at magnesium. Magnesium is an element in period 3 in which we have 12 protons for magnesium. The original configuration is 1s2, 2s2, 2p6, and 3s2. Of course, magnesium, when it forms ion, it will release electrons, and these are the two valence electrons, and magnesium forms Mg2 plus. As you can see, the three elements now form isoelectronic ions. And of course, neon has the same configuration. Yeah, that's why the option is A. Now, let's have a look at question 3, quiz 3. Yeah, problem 7. In this question, you are given 6 IEs, yeah, 6 ionization energies of an element, and you need to predict the most accurate statement for you need to deduce, yeah, whether that element comes from P, S, or D block. See, for this question, you need to calculate the ratios. You cannot just predict. So what I did was I calculate roughly the ratios. IE2 over IE1 was around 2.02. IE3 over IE2, I got it to be 2.14. IE4 over IE3 was 1.33. IE5 over IE4 equals to something around 2.03. And finally, the ratio of IE6 over IE5 equals to 1.329. Now, look at all the numbers. Yeah, look at all the numbers here. 2.02, 2.14, 2.03, and 1.3. No number. We have 3. Yeah, we have 3, 2 point something. So can we say that there is a highest ratio in this case? Tak boleh, ya? We cannot say that because we have 3 almost identical ratios. So in this case, we cannot say that the element is from S block or P block. Yeah, because for S and P block, there will be one highest ratio to indicate a shift in the shells. Yeah. Therefore, in this case, the most accurate answer will be the element comes from D block. Why? Because for D block elements, remember we have discussed before that the difference in energy between 4s and 3D is more or less the same. Yeah. That's why the ratios, yeah, also show you more or less the same ratios. Okay. And let's move on to quiz 4. Quiz 4, question problem number 6. Yeah, problem 6. Okay, that problem was asking about the formal charge of iodine in ICl3 molecule. So if you look at the Lewis structure, you will get something like this. Okay, this is the final structure. You have to start from scratch with two lone pairs around the central atom, iodine. And when you calculate the formal charge, okay, the formal charge will be number of valence electrons for iodine, which is 7, minus the number of lone pairs, the number of electrons as lone pairs, 4. And finally, the number of bonds, the number of dashes around iodine. Okay, that is 3. And you will get 0. Yeah, that is the only answer. Right? Question 7. Yeah, question 7. Or should I proceed to 6? Yeah, 6 first. This question was asking about the bond which is most polar. So you need to calculate the difference in electronegativity. If you calculate the difference in electronegativity between O and F, you'll get 0.5. The values are given. You just calculate from the given values. Cl and H, the difference is 0.7. C and F, the difference is 1.5. And F and F, I don't think you need the values because F and F means same element. Therefore, the difference is 0. As you can see in this case, the most polar will be CF, in which the difference is 1.5. Okay, let's move on to question 7. Yeah, not question 7, sorry, question 8. Sorry. Question 8 was asking about, okay, this is question 8. Where is it? Okay, question 8 was asking about um, a hydrogen bond. So the only not so accurate statement in the options, yeah, in the answers was um, hydrogen bonds exist between polar molecules. Yes, sounds right, but not accurate because for hydrogen bond, this kind of intermolecular forces can only exist between polar molecules with, remember, HF, HO, HN. So this is missing in the explanation. Yeah, that's why it is not right. And lastly, question 10. Yeah, question 10 was asking about the order in the molecules in, I think, decreasing order of molecules in terms of its boiling point. So if you refer to CH3OH, okay, I remember the last one was F2 and FSO2, if I'm not mistaken. Yeah, so CH3OH, it has O bonded to H. That means this molecule can form hydrogen bond. SO2 is polar, but no handphone, no HF, no HO, and no HN. Therefore, it forms only dipole-dipole forces. And F2 is nonpolar. Therefore, it forms only London dispersion forces. Right? So this is the right order of decreasing boiling point because hydrogen bond is much stronger than dipole-dipole forces and dipole-dipole forces are much stronger than London dispersion forces. Okay, I think that should shed some light, yeah? And hopefully you can answer your UPS 2 well this coming Monday. Right? All the best.